In this demonstration, I would like to develop an algorithm which is to count the number of points where the sine of x value is greater than 0.5. And since I'm going to count these number of points, I have to define a step size. So h has been decided as 0.1 for the time being. So the graph of sine of x is a, a curve, a well-known curve. And in this region, as x belongs to 0 to pi, so the range of sine of x values are from 0 to 1. So several values are going to be greater than 0.5. So in algorithm, I will start with a value of x, which is 0, right? I will compute a value y, which is sine of x. And then I have to check, well, of course, for this value, I will check that if y is less than or equal to 0.5, so I have to count this one. It means I have to have a counter initialized. I say n points initialized earlier at 0. So if this is true, then I say n points will be added plus 1. Okay. So and after that, I have to get another value, x equals x plus h, and with this value I have to again get back to the calculation of sine of x, and this process needs to be continued. This process needs to be continued for the time if this x value remains less than or equal to the value of pi, right? So I have not written this algorithm in a very kind of professional way, but I think the listeners and the viewers can develop that the algorithm, right? Let's implement that algorithm in Fortran programming language. So I open a text editor. So I write in the 7th column, it is program p counts, so point counts, right? Point count, and end program is for p count. So points are being counted in this program. I write implicit none, and in the very beginning, I save this program in our working directory. Okay, finally allowed by the system. It should be a Fortran file, and I call it is pcount.for. So, okay. So it has been selected. We recognized. Yes, so it will remain with us as a reminder of what we are doing. Okay. So I have to have an integer counter. So integer counter is n points. I have to have real values x and y. So I initialize, well, I require a pi value, real pi, and pi needs to be defined. Pi, I prefer to define as 4 times a tangent of 1.0. So it is the pi value generated with the assistance of computers and um, Fortran's intrinsic inverse function for tangent. Okay, I initialize a value for x. X is 0, right? And then I calculate and okay, I write the statement of loop do while x is less than uh, less than uh, pi value. Then what to do? Compute the value of sine of x, right? Sine of x. And then I have to see if y is less than or equal to zero point 0.5 value, then there needs to be, this point needs to be counted. So I will write p count is equal to p count plus 1, and that's it. And if, and now the next step is to get the new value. So I write, and here is the the new value, generate the new value. And how to generate the new value? In our algorithm, it is written as x is equal to x plus h. But where is h? So h was not defined. So I instantly forgot that. So needs to be defined as h. And h needs to be initialized. So let's recognize and the practice, make a habit that implicit none, this is the the declaration of variables, and then after defining the variables, then uh, there should be the initialization, and after that develop the algorithm. So h needs to be initialized, so 0.1. So this is the step to update the x value, and then go for the loop calculation. So here there is going to be end do. And finally, let's write a message. How many points were there, right? So I write a print message. I write a message, print the number of points, with value greater than 0.5 are equal to p count, right? So I hope everything is consistent. So let's save this program and run it. So we have to call the file from the system. So this is my folder and scientific computing folder, and this is G77, which is compiler. And to access the compiler, we have to save all of our files in the bin directory. So our file is here, which is pcount.for, and let's call this one from the command window, right? So today I'm going to call command window from here. So I write cmd. So here it appears. I have to get to directory D. There is the directory. Okay, let me show you the address. It is in D directory. Then subject scientific computing G77 and bin. So I can copy this address, copy and cd. Okay, so it is directly over there, right? So another way to access the system, you can either type or see that one from here. I call the function, see the contents of the function, and here is our program, pcount.for. I hope you can all see that one, or I should put a spotlight over there. Yes, spotlight. So you can witness pcount.for. This is the file which contains our instructions for program, and constructions need these instructions need to be understood by G77. Let's see whether it allows or not. So clear screen, G77, pcount, pcount.for. Oh. I think there is going to be a discrepancy. That pcount is the name of the program, and from my previous experiences, this would cause a problem. Our original variable was endpoints, right? So this should be not the endpoints, and it needs to be initialized. Okay, so endpoints, endpoints is equal to 0, and it should be replaced by endpoints, right? So these are the obvious problems that show up when you move from mathematics to algorithm step, and then from algorithm to program, because you have to change the nomenclature. You have to define them in a very in their specific styles, right? So endpoints, right? So this is the reason, that's the reason why typing errors show up while you come to the programming. Okay, so I have sensed that problem, endpoints, and that is because of my earlier uh, discovery experiments. uh, okay, so pcount.for minus o pcount.exe, right? So program names and the variable names, they must be distinct. If you want to experience that one, then experience with the version that I developed before this correction. Okay, so no cry, no sigh, no coughing, no whistle. This is a very dangerous experiment. Oh, the program has been successfully compiled as it seems to be. So we can see a new file in the folder. So I look for the new files. So pcount.for, and there is the application file or the setup file, the application file that has been constructed. So it means uh, the program has been identified and translated to the object binary file. So I can now write pcount.exe, right? So there are 11 points with a step size of 0.1, which are greater than 0.5 value, right? If you reduce it, so what will happen? So if I set that to okay, 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 2.1. So what should be the number? Do you expect 110? Since the change has been made in the main program, I need to delete the file, or otherwise it will be overwritten in in Windows. So I have deleted. Now I generate the new file by compiling it again. So if we run it again, so the number of points are 106, right? Right. So you can check the sensitivity of the number of points as their values are greater than zero point 0.5, right? While doing the scientific calculations and all the scientific work, you have to recognize, you have to identify always a way of comparison, that how you can agree to your results, and what's the logical way to disagree with the results, right? So you cannot have simply the guesses, right? So let's stop at this point. So I have to turn off the stop the recording. Take a deep breath. It calms the mind.